In math, there are various cases where you would want to turn a sum or a difference into a product. For example, we have this rational expression that has x squared minus 2x in the numerator. In order to turn this sum into a product, we factor. And we get x minus 2 over x. After factoring, we're able to reduce and get a non-rational expression. This is just one of the many uses for turning a sum into a product. What if we have a sum of sine of two different angles? Sine of A plus sine of B. Is there a way to rewrite this as a product? Please note, sine of something like alpha plus beta does not equal sine alpha plus sine beta. We have an expression that is equivalent to sine of alpha plus beta. So I am going to rename A and B. A is going to be called alpha plus beta, and B is going to be called alpha minus beta. So the first equation is now sine A is equal to this expression. The expression we started with was sine alpha plus sine beta. So we're going to actually add up these two equations. Sine A plus sine B. Sine alpha cosine beta plus sine alpha cosine beta. There are two of them. So 2 sine alpha cosine beta. Positive cosine alpha sine beta minus cosine alpha sine beta. That reduces to 0. All right, we have it. It's just that unfortunately the left side is dealing with A and B and the right side is dealing with alpha and beta. But I don't want to know sine A plus sine B in terms of alpha and beta. I want to know in terms of A and B, because that's what I'm going to be given. We actually have a way to relate alpha, beta, and A and B. It's these two equations that we came up with at the beginning. To build an expression that is equivalent to alpha, we will go ahead and add these two equations because positive beta minus beta is 0. Alpha plus alpha is 2 alpha. Beta minus beta is 0. And we're adding this, so A plus B. Divide by 2 on both sides. The way that alpha relates to A and B is that it is A plus B divided by 2. It's actually the average of A and B. To write an expression equivalent for B, I'm going to subtract the two equations we started with. So I'm going to actually multiply the second equation by a -1 so that I can add. If you multiply by -1, you can just add. This would be negative alpha. -1 times negative beta is positive beta. -1 times B is negative B. Now we will add these two equations. Alpha minus alpha is 0. Beta plus beta is 2 beta equals A plus a negative B, so A minus B. The way that beta relates to A and B is that it is equal to A minus B divided by 2. This right here is an incomplete formula, right? Because the arguments do not match. You have A, B, alpha, and beta. Too many moving parts. So to complete the formula, we will replace alpha and beta with their equivalent expressions involving A and B. Sin A plus sin B is equal to 2 times sine of alpha. So the argument of sine is alpha. We're going to plug in alpha, which is A plus B over 2. A plus B over 2. And that is also being multiplied by cosine of beta. Cosine of A minus B over 2. This is the formula for turning a sum into a product. How exciting! Now there are actually several of these sum to product identities, and we just proved the first one, sin A plus sin B. So using these identities, let's turn some sums or differences into products. Here we have two examples. The first term is 2 cosine 4 theta. The second term is 2 cosine 12 theta. So it looks like we are looking at a sum of cosines. But each of these doesn't have anything in front of the cosines, right? And here we have a 2. So we need to factor that out so that we have the purest form of cosine plus cosine that we can change to a product. Go ahead and factor out the 2. 2 times cosine 4 theta plus cosine 12 theta. Now we have cosine plus cosine. Go ahead and decide what your A and B are. So I am going to make A the argument of my first cosine, which is 4 theta, and I'm going to make B the argument of my second cosine, which is 12 theta. Now you can substitute the formula. So we will replace this expression with this one. All right, we should have 2 times cosine of A plus B over 2. Okay, A is 4 theta plus 12 theta over 2 times cosine of A minus B, so 4 theta minus 12 theta divided by 2. We're going to simplify the expressions inside the parentheses. Cosine of 4 theta plus 12 theta is 16 theta divided by 2 times cosine of 4 theta minus 12 theta, so negative 8 theta over 2. This 2 is being multiplied by this bracket, but everything inside this bracket is a product, so there's no distributing needed. We'll just simply multiply 2 by this 2 in the front. 2 times 2 is 4 times the cosine of, reduce this fraction, 8 theta times the cosine of negative 4 theta. In the directions it said leave your answer with positive arguments. So you cannot have a negative inside of what you're taking the sine or cosine of. You can have a negative in front. It just, when you leave your answer, you can't leave a negative. Because cosine is an even function, Cosine of a negative input is simply equal to cosine of its positive input. It does not change. So this would be cosine 8 theta, 4 cosine 8 theta times cosine positive 4 theta. You can also write this without the parentheses. However, it's easier for you to understand. And our final example. Yay, they already factored out the 5 for us. So we just need to decide which formula to use and what is our A and B. We have cosine minus cosine. That is this formula right here. Now that we know which formula to use, let's identify A and B. I'll use the first argument of cosine to be equal to A, and the second argument of cosine to be equal to B. 5 times the product, negative 2 times sine of A plus B over 2, 18B plus 6B over 2, times sine of A minus B over 2, 18B minus 6B divided by 2. Continue to simplify what is inside of those parentheses. 18B plus 6B is 24B over 2 times sine of 18B minus 6B is 12B over 2. 5 is being multiplied by the product inside of here, so just multiply 5 by the coefficient in front. 5 times negative 2 is negative 10 times sine of 24B over 2 is 12B times sine of 12B over 2 is 6B. That's how you turn a sum or a difference of sines and cosines into a product.